Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Algebraic Expressions. A big key here is that expressions will have variables, but they will not have an equal sign. So we can only simplify or reduce them. Occasionally we can evaluate. We will not be solving. So you're not going to find out what x is. You can reduce or simplify. If the problem gives you values for each variable, then you could evaluate by doing order of operations. But again, there's no solving because there's no equal sign. So we're going to talk about some vocab, and it's really big in algebra. Depending on your textbook, you might see these words come up a lot, and I use them interchangeably as needed. Sometimes I forget I'm using them and that not everybody knows them. So I'm going to give you the vocab word. I'm going to give you an example. And then we're also going to talk about a degree. And the degree also has vocabulary that goes along with it, but I'm not going to worry about that vocab right now. So in my last video, you might have heard me talk about monomials. Monomial meaning 1. So 6 is a monomial. 9x to the 5th is a monomial. 4x squared y cubed, z, is a monomial. All three of those are monomials. They have different degrees. So this is a degree of 0. This is a degree of 5, and this is a degree of 6. Okay, that's not voodoo math, I promise. What I'm doing here is I'm counting variables. If I were to write it out, how many letters would I write? So 6 is just a number. There's no letters. So that's why it has a degree of 0. 9x to the 5th, that is x, 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 right? So there's 5 letters that would be written after them. Granted, it's the same letter written multiple times, but it would take 6 characters to write, or 5 characters to write out all the letters. In the next one, we have x, x, y, 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 z. So in order to write out all the letters, it would require 6 characters. So that's why this has a degree of 0, and this has a degree of 5, and this has a degree of 6. And those are monomials, okay? Mono meaning 1, or one term. Okay, so our next vocab word is going to be binomial. Okay, I'm sure you've heard of binomial or something with a prefix of bi before. Think of bicycle. Bi is a prefix for 2. So these are going to have 2 terms. X cubed plus 5. 5x plus 1. 8x to the 9th plus 3x to the 4th. These are all binomials. So what separates a term? Well, a plus, it could be a minus, an adding or subtracting sign. Keep in mind that subtracting is just adding a negative. Okay, so they're separated into 2 terms or 2 groups. You separate them by an adding or subtracting sign. Okay, so what's the degree of each of these? Well, the first one has a degree of 3. The second one has a degree of 1, and the last one has a degree of 9. So you might be going, well, wait a second. This had a degree of 6. Why does this only have a degree of 9? Because you go with the degree of the highest monomial. So this monomial has 3. This monomial has 1, and this monomial has 9. So what about if I had 8xy minus 4y squared? Well, This one has 2 variables or 2 characters that it would need. This one has 2, so which is greater, the 2 or the 2? It doesn't matter, they're the same, so we just write 2. The last polynomial I'm going to talk about is a trinomial, which is just an extension of the others. So a trinomial is going to have 3 terms. So let's say 5 plus 3x minus x squared, 1/2 x to the 5th minus 3x to the 8th minus 1/4 x to the 18th. Okay? So, and with both of those, I put the term that had the most power, or the highest degree, at the end. Why? Just to switch it up. So here, this term has the highest degree, so it would be a degree of 2. This term has a degree of 18, so we would say the degree is 18. So again, the degree is based off the highest monomial, or the monomial with the highest degree. If their degrees are the same, we utilize that. Now, when you're dealing with polynomials, you won't see the variables mixed together, and so it's safe to say, hey, the highest exponent. This right here is not written as a polynomial. That would be a function. So that's why I went ahead and threw it in. It's a little more than you might need at this time, but I did want to make you aware that when variables are mixed, it can adjust the degree. Most of the time you're not going to see mixed variables. They're going to stick with A or B when they're at, or X or Y when they're asking you about your degree. So what's going to happen with these polynomials? Because poly means many. You're going to be asked to simplify. Okay, so you might see x cubed minus 6x squared plus 2x plus 4 plus x cubed plus 5x squared minus 7x. So in this case, the parentheses are just saying, hey, here's my first polynomial, here's my second polynomial, and we're going to go ahead and do the addition. Now, some people like to just go ahead and add from here. I have seen some people that want to line it up like you did 2-column addition. So if you like lining it up, make sure that you line up matching degrees. Okay, and the plus sign technically distributes through, but here we've lined up our matching degrees, which would be our like terms. I'm sure you've heard of adding like terms before. The other way that some people do it is they like to color code. So we have x cubed minus 6x squared plus 2x plus 4, and I'm going to distribute that plus sign through as I go. So that would be plus x cubed plus 5x squared minus 7x. And I tell my junior high students whenever we start doing these, if we get this far, or my Algebra 1 students, think of them like shapes. So the brown one reads x cubed. So think of it as a cube. Here I have one cube, here I have another cube. So if I'm thinking about it like physical shapes, I can physically see 2 boxes or 2 cubes in my head. So I have 2 of the x cubes. Okay? Maybe I'm in sales or something. I notice that I only have 5 squares, but someone has asked me to sell them 6, so I need to ship out 6. So I have 5, I need to ship 6. I'm kind of upside down here. I need to go find one more square, right? So I'm in the hole 1 square. Okay, and maybe you think of the x's as xylophones. Here you have 2 xylophones, but you owe the client 7 xylophones. Well, you're in the hole, right? You need 5 more xylophones. And then the 4 was just a 4. I don't have a name for that one or a visualization. We just have a plus 4. Could we have gotten the same things from this vertical alignment? 1x cubed plus 1x cubed is 2x cubed. Notice how we only change the coefficient when we're adding like terms. Negative 6x squared plus 5x squared is negative 1x squared. 2x minus 7x is minus 5x plus 4. So why is it we only change the coefficient but not the variable? I'm going to go ahead and I'm going to show that with just this linear term. Linear, sorry, I brought in another vocab word I haven't talked about. Linear meaning a degree of 1. So if we're looking at 2x minus 7x, by utilizing the distribution process in reverse, we have 2 minus 7 multiplied by x. You think about that distribution. I know I wrote it backwards, but I did. And 2 minus 7 is negative 5. So that's technically why we only change the coefficient and not the exponent. But combining like terms, you only change the number in front. Okay? Multiplying is when we change our exponent. Adding and subtracting is when we change our coefficient. Okay, so that was an adding problem. I'm sure you've seen those before, so it's just a nice little refresher. If you hadn't and I said something new, then awesome, great. As long as we understand it, we're good. I will say adding and subtracting problems, I find my students actually mess them up because they don't pay attention to what the question is asking. And I'll highlight that here more in just a second. I'm going to use the color coding on this instead of the vertical. That way I only write it out once. But if you like that vertical lining up, then great. So here, I don't like thinking of it as a minus. I like thinking of it as x cubed minus 6x squared plus 2x plus 4 plus negative 1 x cubed plus 5x squared minus 7x. So again, we can always write a 1 right here, and subtracting 1 is the same as adding negative 1. So that's all I've done. Let me erase that back out so we can keep that original problem in our brain. Okay, so order of operations says I have to distribute first. So I'll have my x cubed from here. There's nothing in front, so that's why I'm not distributing anything. I'm putting each degree in a different color. So the third power is a different color than the second power, different color than the first power, different color than no power, right? Degree of 0. Then when I distribute negative 1, I'll have negative 1x cubed, negative 5x squared, and positive 7x. Okay, so in pink I have a cube. Over here in pink, I'm shipping out a cube. So if you have one cube and you ship out one cube, your cubes are gone. The shelf is clear. So we're not going to write anything down about that. Here I owe 6 squares, here I owe 5 squares, so combined together, I owe 11 squares. Apparently I don't have any, they're on back order. Here I have 2 xylophones, here I have 7 xylophones, so when I put them on the same shelf, there are 9 xylophones. And here is the 4. So again, if it helps to think of it as xylophones or squares or just a number, then go for it. You know, if it helps to think as negatives as being back ordered, then great. Whatever helps your brain make these problems easier is what you want to go for. This is combining like terms. Technically it works because technically we're factoring out the x cubed and then doing 1 minus 1. Factoring out the x squared, doing negative 6 minus 5. Factoring out the x, doing 2 plus 7. That's technically why it works. But again, keeping in mind the basic rules, once you get comfortable with it, you're probably going to do those pretty naturally. Now, I have a lot of students that treat my next problem, or my last 2 problems, like my next problem, and they're going to be very different. Let that focus. So what you'll see here is there's no symbol in between the parentheses, whereas previously there was a minus separating or a plus separating. Now there is no symbol in between. And unfortunately, I have had students do the first 2 examples like I'm going to do this example. And that's just not following directions. most students in Algebra 1 and then again in Algebra 2 learn about the FOIL acronym, which just helps students keep in mind what they're doing. Really what the FOIL acronym does is it has you distribute your first term. So we would have 2x being multiplied by x squared plus 2x being multiplied by negative 5x plus 2x being multiplied by 4. And then distributing your second term. 3 is being multiplied by x squared plus 3 is being multiplied by negative 5x plus 3 is being multiplied by 4. And I wrote that out completely. Some of you may not need it quite that written out, and that's okay. But that's really what FOIL did, that first outside, inside, last, because you only had a binomial multiplied by a binomial, so you only had to do the first, outside, inside, last. But now by adding a third term or making the third one a trinomial, then it sometimes is harder to see. So this is kind of doing it horizontally and doing double distribution. And then you can go ahead and actually do that product. So 2x cubed plus negative 10x squared plus 8x. And I generally don't write plus negative. I just wasn't thinking. It's minus, right? Plus 3x squared minus 15x plus 12. And some of you might have done all of that in one line naturally. And then we're going to add like terms. So there's only a 2x cubed. Here's the x squared, so negative 10 plus 3 is negative 7. Here's a plain x, and here's a plain x, so plus 8 minus 15 makes negative 7. And then there's that plus 12 at the end. And this is also written in standard form because the power is going down as you go, or descending order. Okay, there are two other methods that I'm going to redo the same problem with, just so that you can work on visualizations. So in your younger years, you might have done multiplication where you did like a 3-digit number times a 2-digit number, and you might have written it like this. And I hesitate to use the actual times sign there like that. So I'm going to kind of scratch it out because I don't want you to think of it as an X. Okay, and then you would have done, so to do this like you would have done that, we'll start with a 3. 3 times 4 is 12, 3 times negative 5x, 3 times x squared, placeholder, right? You remember doing the placeholder back in the day? 2x times 4, 2x times negative 5, 2x times x squared. And then you would add 2x cubed minus 7x squared minus 7x plus 12. That's completely acceptable to do. The way I have my Algebra 2 students do it is more kind of using a Punnett square idea. Because it's a binomial times a trinomial, I do a 2 by 3 box. I don't care whether it's 2 by 3 or 3 by 2. 2x plus 3, x squared minus 5x plus 4. And there are now 6 boxes, so we have to fill all 6 of those in. 2x times x squared is 2x cubed. Negative 10xx makes negative 10x squared. 2 times 4 is 8 with an x. 3 times an x squared. 3 times negative 5 is negative 15 with an x. And 3 times 4 is 12. So again, no matter which way I'm doing it, I'm getting the same 6 terms to add together and combine my like terms. All it is about creating a way that helps your brain feel comfortable. A lot of times your like terms that you're adding are diagonal from each other. Not always, but a lot of times. So which way is your favorite? Just doing the horizontal, doing like a 2-column type multiplication, or doing a box? That's definitely up to you. It's just whatever you are happy with. There are a couple of things that are quick patterns that you just need to know about, and a couple errors that I know happen on a regular basis. So let's think about this. Okay, a plus b here is being multiplied by a minus b. So if we were to multiply this together, I'm going to use the horizontal method. And you can think of it as a FOIL acronym. I'm going to think distribution. So we're going to distribute the a, so a times a times negative b. Now I've got to multiply by b times a. I always write them alphabetical order, because who cares whether it's b, a, or a, b, it's the same product. And positive b times negative b. Now you might notice, I think of these as a basket with apple, apple, a basket with apple, banana, basket with apple, banana, basket with banana, banana. But we owe one apple, banana, we have one apple, banana, so that clears off our shelves. And I'm left with the double apple basket minus the double banana basket. So this pattern, going from a plus b, a times b, or a times a minus b, to a squared minus b squared, and going back as well, is a frequently used pattern. And it really is a good idea to just know this rule. When you see something where everything is the same except one's a plus, one's a minus, by the way, those are known as conjugates, extra fun vocab word, they will always equal the first thing squared minus the second thing squared. Or if you see something squared minus something squared, can you go back to these factors? Yeah. It's kind of like saying 2 times 5 is 10. So 10 is 2 times 5. We can either multiply or we can factor it out. Either way. But here's where I see the error is whenever people have something like a plus b to a power. They think they can just do the same thing. So let's do a numerical item. 2 plus 8 to the third power. Okay, I have in variables, okay, I have a lot of students that would be like, well, it's kind of like when, in that previous video I posted where you just did each thing to the third power. 2 cubed plus 8 cubed. Well, 2 cubed is 8. 8 cubed, I forget that one off the top of my head. I think it's like 516 or something. 512. And if you add those together, we get 520. Okay, but if we do order of operations, you're supposed to do parentheses first. By the way, this was bad. No. Big no-no. 2 plus 8 is 10. And 10 to the third is 1,000. So we see here that that plus sign, the fact that this is a binomial, not a monomial, means that those rules that happened in the last video do not work. The plus sign changes everything. Okay? So anytime you see these, they must be quote unquote foiled out. There's a math meme. If you are a person who likes memes, it's one of the Save the Animal memes, and it's about puppies. And if you make this error, they say that you killed a puppy. Stop killing the puppy. Save the puppies. Okay, we like dogs. So what does that mean? Okay, well, let's just look at a squared one. Keep it simple at first. 3x plus 5 squared. Again, it's not just going to be 9x squared plus 25. That would be making that error. That would be not saving the puppies. Save the dogs. So I'm going to go ahead and I'm going to use the grid method, the 2 by 2 binomial, or Punnett like square, or if you think about it back to maybe elementary school when you did the area model, it's kind of the same idea as the area model. But we're taking 3x plus 5 and we're multiplying it by 3x plus 5. So 3x times 3x is 9x squared. 5 times 5 is 25. So we are getting the 9x squared and we're getting the 25. I'm not saying that that wasn't completely there, but we're also getting 3x by 5 is 15x, 5 by 3x is 15x. We're also getting an additional 30x when we put those together. When you shortcut it with a plus sign, you're losing these middle two terms and you're missing this piece, and that's why we got too small of an answer, because we missed out on the stuff in the middle. Unfortunately, when we get to higher powers, this does get a little tedious unless you know how to use expansion by Pascal's triangle, which is kind of a cool little trick, but not everybody's comfortable with expansion by Pascal's triangle. And since today's focus is on, polynomial operations, not expanding Pascal's triangle, we're going to do this the long way. Okay, so what does it mean to do x squared minus 2 cubed? And just quick note, no, this will not be x to the 6th minus 8. No, not it. Don't shortcut it, because the minus sign says we cannot shortcut it. So I don't know how many times I can say that. Hopefully it'll get stuck in your brain. So what this really means to do is x squared minus 2 multiplied by x squared minus 2 multiplied by x squared minus 2. Okay, so let's think of on a side note. How do I do like 4 times 9 times 5? I can do this one in my head. You may not be able to. I don't know. I bet if I showed you how I did it in my head, you could. So I don't like doing this order. I'm going to go ahead and commute it really quick. 4 times 5 times 9. I'm going to do 4 times 5 is 20, and 20 times 9 is 180. So I multiplied 2 of them together, and then I took it times the third one. That's what we're going to have to do here, is we're going to have to multiply 2 of them together. Do I care which 2? No. I'm going to multiply those 2 together first, and then I'm going to multiply by the third one. Okay, so let me bring down my x squared minus 2 that I'm not using yet. And then I'm going to do my FOIL work. And this time I'm just going to write it horizontally. So I have my distributing my x squared, so that'll be x to the 4th minus 2x squared. Now I need to distribute my negative 2. So negative 2x squared plus 4. And before I multiply again, because right now I have a binomial times a polynomial with 4 terms, I'd rather turn that into a trinomial. So I'm going to simplify it. I'm going to write x squared minus 2. And when I combine like terms, I'll have x to the 4th minus 4x squareds plus 4. Okay, and now I need to multiply again. Again, I'm going to double distribute. I'm just going to color code this one a little bit more. Right now I'm going to distribute x squared. Again, you could use the 2 by 3 grid. X to the 6th minus 4x to the 4th plus 4x squared. And now I'm going to distribute the negative 2. Negative 2x to the 4th plus 8x squared minus 8. So our first term is x to the 6th. This has a power of 4 and this has a power of 4. So when I put them together, I get negative 6x to the 4th. So I've used them. Notice how I'm kind of checking them off as I use them so that I remember. Here's a 4x squared and an 8x squared. So there's 12x squareds. And then the only thing left is the minus 8. So that shortcut would have only had the first and the last terms, but there was so much more here. So make sure when you have something to a power, you have to expand it or FOIL, in quotes, it out. And I'm just using the term FOIL as that acronym that you might have learned in Algebra 1. First, outside, inside, last. Now, if we're going to multiply these things, we also need to be able to go backwards. For example, yes, we know that 2 times 5 is 10, but we also, with 15, can go backwards and say, hey, it's 5 times 3. So when we go backwards, this is known as factoring. Here we multiplied. Okay, and we like to factor till we get prime numbers. So when factoring, the first thing you always check for with factoring is a GCF. Always, 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 whoops, check for your GCF. GCF means greatest common factor. For example, 4x plus 8 has a GCF of 4, and it would be 4 multiplied by x plus 2. So see how we went from a adding problem, in this case, to a multiply problem? That's our goal. Okay? Then after you check for GCF, you can use guess and check to unfoil it. There's also AC methods. There's several methods. And I have some videos in my Algebra 2 that playlist that is extensive for all the methods to factoring. So if you don't get enough in this video, go check those out. Your goal. By the way, guess and check is going to be your fastest way if you're comfortable with factoring. And you need to get to that point with your college math so that it doesn't take you too long on your exams. Your goal is to have no exponents inside your parentheses and to write your polynomial as a product. That's really what the word factor means, is to write it as a product. Now, are we going to always be able to get no exponents inside our parentheses? No, we're not. If you have a graphing calculator, I'll give you a hint, is that if you were to graph each parenthesis separately, if that parenthesis crossed the x-axis at a rational number, you can probably factor it more. If it crossed at irrational numbers or not at all, you may not be able to factor it. So just a quick key. You have to understand how your graphing calculator works to be able to do that, but okay, so 3x squared minus 6x. What I notice here is that 3 and 6 are both, each term divides by 3, and each term has an x in it. Because they have something in common, they have a greatest common factor. They both divide by 3, and they both have an x. So you can also think about it like, I'm giving you the inside of the boxes. You have to give me what's outside. So since they have a GCF, that would be a monomial. So we need a monomial, and now we have to fill in both things on the top. So we would need an x here to create the x squared, and we need a negative 2. So it would be 3x multiplied by x minus 2. Now the reason I bring the idea of the box up is, let's say we have 8x cubed minus 4x. Okay, I have a lot of students that write 4x 2x squared. This is not correct. This is bad. Okay, so let's see, why is that bad? Well, I agree that there is a GCF of 4x. And anytime you have a GCF, we would need a monomial. There's two terms, so we have to have two boxes, right? 8x cubed minus 4x. So when we're factoring, they give us the inside and we have to get the outside. So I agree that there's a 2x squared here, but that only gets us that first box. What do I need to get my second box? And the thing is I need a minus 1. So when you're factoring out a monomial, or the greatest common factor, the number of terms inside here needs to match what's in here. Now, I did tell you that if you understand how your graphing calculator works, that there's a little trick. Okay. Could I factor this more? Yes. Could I do it with integers? No. So I'm going to go to my y equals 2x squared minus 1. Okay. And this says something about my window range, so really quick, hit quit. in my window, I always, see how it says the x-min and the x-max are both 10? It's trying to start at 10 and end at 10. You can't do that. So we're going to start left 10, and we're going to go right 10. And I'm having it number by ones. And then I'm going down 10, up 10, also numbering by ones. So this is my favorite window. I always do my window manually. I never trust the calculator to do that. And I'm going to go ahead and graph it. Okay, so it definitely crosses at a fraction, but is the fraction rational or is it irrational? If it crosses at like 1/2, this factors. If it crosses at a really, really long decimal, then it doesn't end and doesn't repeat, then it's not. If you're in my classroom, using this trick is not going to really get you everywhere you need to be because I grade you on showing your work, but am I going to know you double checked yourself on the calculator? Maybe not. So I'm going to come in here and there's the calculate menu. And I'm going to calculate where it crosses the x-axis. So I'm going to calculate where it crosses the x-axis is a vocab word known as 0. So you can arrow down to 0. I'm going to punch the number 2, so I type 2. And see how it says left bound? I'm going to get to the left of this 0 because I'm going to talk about the negative 0. So I'll get to the left. I don't care how far left you are. And I'm going to hit enter. Now it says right bound. I don't care how far to the right you get as long as you don't go past the other 0. So I could get to right here, or right here, or here, or here, or here, or here. I don't care. You'll notice that there's 2 light blue lines with arrows pointing in. It crosses the x-axis between those 2 lines. It does say guess now. I just hit enter when it says guess. Okay, this is a very long decimal. I happen to know that this decimal is the square root of 2 over 2 because I deal with it a lot in trig. This is not rational. So because this decimal goes on and on and on, I know it looks like it stops. It doesn't. It keeps going. Because of that, just so you know, 0.707, it does. This screen shows it going on more. Because of that, I now know that this is prime and that that's as far as I can factor this particular problem. So if you're ever stuck, you can put everything in terms of x and double check it. If it has x's and y's and z's, it's a bit harder to check. But if it just has one variable, just utilize x. You can check it like that. If it crosses at weird numbers, then it doesn't factor. Okay, so your GCF can be multiple variables. So we can see that these have things in common. So I'm just going to do a monomial times a trinomial. Why a trinomial? There's 3 terms. 8x to the 4th y squared. Again, they're giving you the inside or the area, and you're trying to come up with the length times the width, basically. Okay, so they all divide by 2. They all have at least one x, and they all have at least 2 y's. So 2 times 4 is 8. There's 1x here, so we'd need 3 more here. And the y squared's already taken care of, so we're good. When we put those together, we would get that. 2 times positive 3 is 6. We'd need 2 more x's and 1 more y. Now when we put those together, we would get the second term. Minus 1, because 2 times 1 is 2. They already have the x, but there's 2 y's here, so we would need 2 more y's to make the last term. So my factoring is 2xy squared, the quote-unquote length, times the width, 4x cubed plus 3x squared y minus 1y squared. Do I have to write the 1? No. I thought you might like that. Now, I know that I put this next problem on several of my tests. Sometimes it's just on a chapter test, sometimes it's on the final. It really is a simple problem, but I have students that make it way, way, way too hard. So I'm going to do it the simple way first. Okay, there are 1, 2 terms separated by a minus sign, right? So I'm going to see if it has a GCF. To x plus 4, x minus 3, negative 5, x minus 3. Is there something in the first box that's also in the second box? Yes, there is. An x minus 3. The first box is the parenthesis x minus 3 multiplied by the parenthesis 2x plus 4. The second one is the parenthesis x minus 3 being multiplied by minus 5. So now I've actually found my length and my width. My length is x minus 3. My width is 2x plus 4 minus 5. Now, can I simplify this? Absolutely. I can take this a step further and make it x minus 3 multiplied by 2x minus 1. Because plus 4 minus 5 is minus 1. And I'm done. I know I put this on my test the last couple years, and I did it with one that was more complicated. And I had students that took way too long on it, and I had some that just multiplied it out. Here's the common mistake they did, and here's what they could have done to fix it. I had students that did this. So they did first, outside, inside, last, distribute the minus 5, combine like terms. So that'd be negative 2, negative 7. And they stopped right there. They expanded it, which is great, but this said to factor it. Factor it means we need to write it as a FOIL problem, right? So how could we write this as a FOIL problem and reduce that FOIL process? I'm going to go ahead and do it with a grid for now. Some of you guys can do guess and check. So we know when we FOIL, and again, if this video is not enough for you to gain this, and I'm only doing it this way because my A value is 2, not 1. When it's 1, it's so much simpler. We know we have 2x squared here. We know we have positive 3 here. And we know we need these two boxes together to combine to make negative 7x. Okay, now I know the only way to multiply to 2 to x squared is a 2x times a 1x. But for positive 3, it could be 1 times 3 or negative 1 times negative 3. I always put my negatives on my constant, not my lead coefficient. Well, since there's negatives in the problem, I'm probably going to use negative 1 times negative 3. But here's the thing. If I put my negative 1 here and my negative 3 here, that makes negative 3x minus 2x. Negative 3 and negative 2 do not make negative 7. This is why I call it guess and check. So I'm going to flip-flop. I'm going to put negative 1 down here and negative 3 up here. So how did that affect what goes inside the boxes? Well, now negative 3 times 2 is negative 6, and 1 times negative 1 is negative 1. Now, negative 1x minus 6x is negative 7x. So I can say my length, quote unquote length, right, is x minus 3, and my width is 2x minus 1. And I was able to get to that same thing. Now, had I just done the GCF, it was faster, but I didn't. So this actually leads into how the book properly teaches how to factor versus the guess and check method. So let's look at x squared plus 7x plus 12. I'm going to pick something on purpose, and then I'll explain to you why I picked it in a moment. I'm going to rewrite this as x squared plus 3x plus 4x plus 12. And I'll explain why I picked 3 and 4 in a moment. If I just look at these first two terms, I see a GCF of x with an x plus 3. If I just look at these two terms, I see a GCF of 4 with an x plus 3. Now if I look at the green versus the blue, I notice that they both have an x plus 3. And if I take that GCF away, that would leave me with an x plus 4. Why 3 and 4? Well, because 3 times 4 is 12, and 3 plus 4 is 7. So I multiplied to this number, and I added to this number. Why did the two numbers that wind up here end up here? Because there was a 1 out front. If there's any number besides a 1 out front, that method does not work. Okay? Now, I do want to come back up just in case you're a person who's like, factoring is hard for me. Like, come on, you gotta have something to help out. Let's come back to this problem. And we'll just start with this one. Will your instructor know that you're using the calculator to kind of guesstimate it out? No, they won't. So let's look here at this graph. We notice that it crosses at -4 and -3. Look at the relationship. This is +3 and +4. So these were negatives, these were positives. See how it was the opposite inside the parenthesis? Okay, so let's come back up and let's do this first one. Okay, so I have it exactly as it was written in the expression. Graph it. Okay, so we can definitely see it crosses at 3, and if you're ever worried about it, use that calculate menu, but I'm going to choose number 1 instead of number 2, and see how it has a flashing cursor. So I'm going to type 3, and it did. The second one looks like it's at 1/2, so let's check. So since I'm still in that menu, I haven't done anything else, I can just go ahead and type 1. See how it puts it next to the x? And oh yeah, it did cross at 1/2. So it crossed at 3 and it crossed at 1/2. Do you see how 3 makes that parenthesis 0? And 1/2 makes that parenthesis 0? 2 times 1/2 is 1, 1 minus 1 is 0, yeah. But we normally do not want fractions inside here, so if we think about it as x equals 1/2, multiply both sides, move everything to one side. Okay, kind of showing you some extra stuff in there too. But if you get stuck, is that a way to double check your final answer? Yes. However, if it's written like this and you don't show the GCF step or the multiplying it out step to get your two factors, your professor might know that you just used the calculator and they might only give you partial credit. So please try to show as much work as accurately as possible so that you can show that you do have an understanding of it. You're just using your calculator to check. Okay, so 5a plus 1 squared minus 2 times 5a plus 1 minus 3. This particular example has a long way and a short way. Okay, long way, I will do second. Short way. Let p equal 5a plus 1. And substitute. By the way, p stands for parentheses in my mind. So instead of writing 5a plus 1 squared, I'm going to write p squared. Instead of writing minus 2 times that 5a plus 1, I'm going to write minus 2p minus 3. And we're trying to factor this. I guess I should have said that to begin with. Okay, so I'm trying to reverse and make it a multiply problem, right? Well, the only way to multiply it to p squared is p multiplied by p. And we need to multiply to -3 but add to -2. That would be -3 and positive 1. And you should be able to do that step in college math when you have a coefficient of 1. Again, if you cannot, please, please, please go back and check my factoring video in my Algebra 2 playlist. It has all this factoring really explained in a really long video. Now, our original problem did not have p's in it, so now we have to undo our substitution. 5a plus 1 minus 3, 5a plus 1 plus 1. So see how I just changed p back now? And then I can simplify. 5a minus 2, 5a plus 2. Okay, method 2. We're just going to grind this out. So I have to square it, which means I'm going to FOIL it by itself, and I'm going to shorthand this a little bit. 25a squared plus 10a plus 1. I went ahead and combined like terms there. Minus 10a minus 2 minus 3. So that's going to leave us with 25a squared. These are going to cancel. 1 minus 2 minus 3 makes minus 4. And now I know that's that special pattern, difference of two squares. 5a plus 2 and 5a minus 2. I know that because it's something squared minus something squared. In other words, I could square root each part, and there was a minus separating. That's why I knew I could go back. Okay, so it really is a big deal that you be able to understand what factoring looks like. There's also just some special rules that you got to keep in mind. Again, I just said something about a squared minus b squared. Goes back to a plus b, a minus b. The next one is a little bit harder to get if you don't know how to do synthetic division and you don't have it memorized. A cubed plus b cubed. If it's a cubed plus b cubed, you'll have a plus b, a squared minus ab plus b squared. If it were to be, instead of a plus, if it were a minus, then this would become a minus and this would become a plus. That's the only difference in the two rules, but these two rules can be very, very helpful when you're factoring if you have a difference of two cubes or a sum or difference of two squares. Again, I don't like memorizing rules, so I do just like to go ahead and create methods that we can go ahead and factor those as well. So let's go ahead and let's just see if we can get some of these going. So 4x squared minus 4xy plus y squared. Okay? Notice that the powers go 2, 0, 1, or in reverse 0, 1, 2. Now, anytime it starts with a number, okay, I'm going to think about what multiplies to AC and adds to B. So our A is 4 and 1. 4 times 1 is 4. And our middle term of B is negative 4. So can I think of two things that multiply to 4 and add to negative 4? Yes, absolutely I can. Negative 2 and negative 2. So I'm technically changing this to 4x squared minus 2xy minus 2xy plus y squared. And I'm doing this the proper way. I'm not doing this with the grid in this case, because I want you to go ahead and be able to see some of those. My old factoring video, that has the gridded out method. Okay, so now I'm going to factor by grouping. There's 4 terms. I'm going to split it into 2's and 2's. So these two have a GCF of 2x, leaving me with a 2x minus y. These two have a GCF of, since the first term is negative, I'm going to do negative 1y, leaving me with 2x minus y. Now, the first group and the second group have that common term of 2x minus y. And when I take that away, it leaves me with 2x minus 1y. Or I could also write 2x minus y squared. Could you have guessed and checked that? 2x and 2x, negative 1y, the outside plus the inside make negative 4. Absolutely. If you can guess and check, you're a rock star. But if you're not and you need that multiply to AC, add to B method, absolutely. Could you have taken these 4 things and put them in like a 2 by 2 Punnett square? Absolutely. Okay, so the difference of 2 cubes and the sum of 2 cubes rule, I find that a lot of people just do not remember the rule. So I want to give a way that we can look at it as well. So 27x cubed minus 1. So 27 is 3 cubed, x is x cubed, and 1 is 1 cubed. So everything here is something to the third power. Now that rule said, or I could rewrite the first part as 3x cubed minus 1 cubed. I could rewrite the rule with just the minus, right? It went to a minus b, a squared plus ab plus b squared, which means instead of a, I have 3x. So 3x instead of b, I have 1. So instead of a squared, I'd have to do 3x squared, and 3x times 3x is 9x squared. A times b, so 3x times 1. And b squared, so 1 squared is 1. And then generally when you use this rule, you do not break this down additionally, or if I were to graph just that part, the 9x squared part, 9x squared plus 3x plus 1. And if I look, it doesn't cross the x-axis. So that's one of the other reasons why this does not factor more, and then that trinomial here is in reduced form, as it does not cross the x-axis, so there are no real roots. So if you do get stuck, check it. If it doesn't cross the x-axis, it doesn't factor. I have a lot of students that know, look, 27 is 3 cubed and x cubed, and 1 is 1 cubed, so they can get this part. But they have trouble with coming up with the top. And they know it's supposed to have 3 things in it, they just forget what those 3 things are. But we start off with 27x cubed, and we end with negative 1. So 3 times 9 is 27, and 1 times 1 is 1, but they have trouble coming up with this middle part. So that's when I come in and go, all right, this would be positive 3x, and this would be negative 9x squared. But we know those need to cancel out because they weren't in the original problem. So this would be a positive 9x squared, and this would be a negative 3x. And then because of that, we can see that if I were to take these two things and multiply them by 3x, I would get these two things. And now I can see my 3x minus 1 and my 9x squared plus 3x plus 1 without utilizing the rule at all. So utilizing that Punnett square type grid, just expanded, really gave me that option. So let's try that again without the rule. Again, you can always use the rule pattern, you just have to understand it. If you don't like the rule, this is how to do it. X to the 6th plus 8. And you might be going, well, x to the 6th isn't something to the third power. Absolutely it is. It is x squared to the third power, and 8 is 2 times 2 times 2, so 2 cubed. So again, we know we need that rule, but we don't like memorizing the rule, so we're going to do a 2 by 3 grid. We know we're starting with x to the 6th and 8, and we know everything else needs to cancel out. We know that this is x squared to the third power. We know that this is 2 to the third power. All right. So we would need an x to the 4th here. That way 2 x's and 4 x's make 6 x's. And we need a 4 here because 2 times 4 is 8. Now, that would put a 4x squared in this box and a 2x to the 4th in this box. But those two things are not in that original problem, so they had to cancel out. And now what would I have to multiply the two things out here on the far left to get these two things in that middle column? I need to multiply by negative 2x squared. So that's why my final answer is x squared plus 2, x to the 4th minus 2x squared plus 4. Okay, so again, we were able to factor. Now I will tell you that the original problem here did not cross the x-axis at all. It didn't, and yet we were able to factor that. So really checking to see if it works only usually works for lower powers. Once you get past a power of 2, it really doesn't help them best, but in general it can probably help you. If you were to say have x to the 6th minus y to the 6th, I would first make this x cubed plus y cubed multiplied by x cubed minus y cubed by using the difference of two squares. Then after that, I would do the difference of a sum of two cubes and difference of two cubes. So x plus y, x squared minus xy plus y squared. And then for the second parenthesis, x minus y, x squared plus xy plus y squared. And this would be factored completely. Again, we're trying to have no exponents inside and factor as much as possible. Okay, so 2x to the 4th minus 8x squared is going to be our next example. And 2 and 8 are both even, and they have variables in common, so we have a GCF, which would leave us with x squared minus 4. Now, technically, this is 2 times x squared minus 4. So technically, even though there's an exponent out here, it's not really inside the parenthesis, and our goal is to stop the exponents being on the inside. However, this does factor more. It's that difference of two squares pattern. X plus 2, x minus 2. Now we've gotten rid of all the exponents inside of our parentheses, and now we're factored completely. All right, let's try x to the 5th, y squared, minus xy to the 6th. No numbers, I know. It's all right. I know we have exponents as numbers, but no coefficients. So we do have a GCF. They have variables in common. They both have one x and a y squared, which will leave us with x to the 4th minus y to the 4th, which is a difference of two squares. So we'd have xy squared, x squared plus y squared, x squared minus y squared. Now, this is a plus. It is not a difference of two squares. It's done. A sum of two squares does not factor because it would if you wanted to use imaginaries, but we don't want to use imaginaries. However, this here is difference of two squares again. So this one here would factor to an additional x plus y, x minus y. So remember to make sure you factor completely. A sum of two squares is okay. You can leave it. A difference of two squares, you've got to factor that. So understand when it's factorable and when it's not for some of those basic patterns. Again, graphing can help you. It just doesn't guarantee you. It generally is pretty good for variables of just power of x. What about if they give you 4 terms? X to the 3rd plus x to the 2nd plus 4x plus 4. You could go ahead and put it in that Punnett square and try to pull it out. And I'm going to go ahead and just write that here. If you go back to my Algebra 2 version of factoring, you'll see that I explain utilizing the Punnett square. But a lot of college professors are going to expect you to move up a level instead of just going, oh, what's the GCF? What's the GCF? What's the GCF? What's the GCF? And so we're going to assume that you have that college professor that needs you to do something different. So we're going to factor by grouping. So I'm just going to pair them up. GCF of x squared would leave me x plus 1. Okay. Over here, we have a GCF of 4, positive 4, right? Because they're both positive, leaving me with x plus 1. Now what's in brown and green, they have a GCF as well, and we can look at that because they're separated by a plus sign, right? So what does the first thing have that the second thing also has? They have an x plus 1, leaving me with an x squared from the first group, right? Because x plus 1 times x squared, plus 4 from the second group. This is a sum of two squares. Because it's a sum, we're done. We stop. Okay, let's try another one of those. X to the third minus 2x squared minus 9x plus 18. Factor by grouping, so these two both have an x squared, leaving me with x minus 2. Now, since the second term starts off with a negative, I'm going to use a GCF that's a negative. The second, I'm going to GCF negative 9 because I want a positive number in the start of my parenthesis. So negative 9 times negative 2 is positive 18. Okay, and does the brown and the green have a common term? Absolutely, they have a GCF. We can factor out an x minus 2. First one is x2 times x squared. The second one is x minus 2 times 9. And now we've written it as a problem, as a product. We went from an adding, subtracting problem to a product. However, x squared minus 9 is not prime because it is that special pattern. It's that difference of two squares. So we'll have our x minus 2. And then x squared minus 9 unboils to x plus 3, x minus 3. And for those of you who are wondering, x to the third minus 2x squared minus 9x minus 18. When I graph this, by the way, if your calculator's graphing slow, I'm going to hit the on button. Plus I typed it in wrong. I'm going to go into format, and at the bottom I'm going to turn asymptote detection off, and I'm also going to come back and make that a plus, not a minus. Typos are bad in your calculator. We can see it does cross the x-axis 3 times, at negative 3, at positive 2, and at positive 3. So that's why we're getting 3 perfect little parentheses, is because it crossed at 3 perfect little locations. So again, if you get stuck factoring and this video is insufficient, please, please, please go back and grab that other video out of my Algebra 2 playlist about factoring. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.